Okay, I Rachel Rayed some of this, meaning that I had some of the ingredients all put together so that I can show you quickly how to do this. But this is how the easiest way of making a predicted and an actual in the same columns. You would go to your original sheet of data, which this is my original sheet of data, and copy and paste all the independent variables. Those are the variables that are used as inputs for predictors, and copy them. They might be separated here and there across your spreadsheet, so you have to have them all in a row. That's going to be easiest for you. Mine happen to be all in a row, and then paste them into a new sheet. I call my sheet 3. I put the age, the height, the weight, the push-ups, and the sit-ups. Those are all my X values that I'm going to plug into my formula to predict the Y value. Put them all in here. Predicted is going to go into here, and that's a column, and then the actual data is going to go here. Like, this is what you're trying to predict, the runtime score in my case. So let me change this to actual runtime score. The neater you are up here, the easier life is going to be for you when you make your plots. Now, how do you get your formula in there? Well, take the formula you just got, which I have here, copy and paste this. If you haven't watched the other video on how to come up with this and put it into your spreadsheet, you need to go watch that. So how I get this formula, how I extract this formula, that's on an earlier link. And then you put this into this slot. I recommend going into the little click the link, click the cell, and then go into the little box, because you have more flexibility in working with the formula. Erase the Y, the 2-mile run, which is what you're trying to predict, because the hope is you'll plug in the information from your Excel spreadsheet and the equal sign tells it to do the calculation. Now, instead of sit-ups, my sit-ups are in column E. I'm going to put times E2. That's going to be the sit-ups being plugged in, and you can see it's highlighted up. Instead of push-ups, I'm going to put D2, because that's the column that has the push-ups in it. So the number of push-ups get put into here. The body weight, which is in pounds, gets put into here. The height gets put into here. The age gets put in. And see, I'm putting the asterisk for times age, A2, gets put into here. And this is my intercept, so I just leave it alone. I hit enter, and I get a prediction. Doesn't look too bad compared to this actual runtime score. It's a little bit off. All right, so how do I get it down to the next? You can drag and drop. I have 8,000 some people in here. I don't want to drag and drop. Just take your mouse, when it becomes a thin cross at the right bottom corner, double click, and it fills in all your predicteds. That's how you get your predicteds in there. Now, for everything else, it's super easy from here on out. If I want to get, I asked you for actual versus predicted, that's just highlighting these two, hitting insert, going to scatter plot, and then you have this graph. It looks like there's an outlier here. I'm going to put my, make it nice. So go to that quick layout up here and choose this. And let's make this, the X values here were the predicted. In seconds. Make it all look nice. Put the nice graphics on here. And this will be the actual. So one of the actuals looks like it's way off unless that person bear crawled their whole 2-mile run time in seconds. It might be valuable for me to find that point and delete it, but I'm not going to do this as just a show and tell. Well, maybe I should. If you see some anomalies like that, all you have to do is highlight it. It says it's 9559. We can find it. Actually, yeah, it's almost 10,000. So let's find it. So you just go like this, find 9559, and there it is. This is definitely an anomaly. Somebody mistyped it. I'm just going to delete that row of data. By the way, that was in my model too, so it's messed up. But now we have this. And it doesn't, I see two little chunks here. I'm going to guess one is males and one is females. That's probably why. But you can now make the line of regression in here, add trend line. And if it was a good model, the slope and the y-intercept and the r-squared should look good. And I see it here. Let me scoot it out here. It doesn't. The slope actually looks close to 1. The y-intercept looks kind of close to 0. So on average, it's doing well. But the r-squared between actual versus predicted is very bad, 0.08. That's not close to 1. That number should be close to 1. You want to report that. So in your equation, you would actually put this information into your template. This is why I ask, make this trend line between actual versus predicted. If they were in good agreement with each other, the slope should look close to 1, and the y-intercept should look close to 0, and the r-squared should be very close to 1. So all those things need to be reported in your template, just to see how good it was. I'm going to stop this video. This is this part of the video, is just to how to get your predicted and actual next to each other. Next part, I'm going to show you how to get MAD and MSE from this.